Hi, today I'm going to go over the Data and Information Management and Solution Development question from the November 2021 theory paper of the IEB. Right, so let us go down to that question. I'm just going to do a Control F 7.1 because it's question 7.1. Okay, so let's read the question. So it's all about some garden services. And they make, so AJ Garden Services make use of several OOP design programmed in their business to keep track of their customers, orders, and accounts. When developing an any application built along OOP principles, there are established processes involved using computational thinking. Explain the importance of the following two processes. You need to mention 2 facts per process to show why each is important. They're looking for 2 facts per process. Let's go to the computational thinking section of your SAG document. If you look here, it's topic 4. And this is computational thinking. In grade 10, you need to learn certain things. In grade 11, grade 12. And the key words, the words we want you to know are decomposition, pattern recognition, abstraction, algorithm, and evaluate. Okay. So those are all the words. Please make sure you know these 5 words and what they mean, how you do them, to do problem solving using computational thinking. So let's look back at the question. And the 2 that they've honed in on here are decomposition and abstraction. Okay, so you could talk about anything to do with decomposition. If you look back at the SAGs, what it means is that you break the problem into smaller parts. That's important to say. You want to break the problem down into smaller parts. You want to say that it makes it easier to solve the problem, makes it easier to work with the problem. You can give different teams different parts of the problem. And if we look at the solution, it says, understand, these are all the things you would get a mark for. Understand the problem, break down into smaller parts, separate the interface from the working code, identify storage, and create goals and sub-goals. The other one is abstraction. Now, if you look at the SAGs, what does abstraction mean? It means you must identify what is important and ignore the things that are not important for this problem. Often when you get given a problem, you will find that a whole lot of facts are mentioned, and you've got to sort of look at the problem and decipher, okay, this is important to solving this problem, and this is not important. And that is what abstraction is. So let's see what they wanted us to say about it. You should reduce complexity, decide on the best data structures, design the classes, make use of information hiding, any 2. And I'm sure if you'd mention anything that is in the SAG document under abstraction, you would get marks for that. Okay, make sure that you, when we ask you for, it says 2 facts per process, make sure that you mention 2 different facts. Don't just say 1 fact and then say it to me again in different words. That's still going to just be 1 mark. This was for 4 marks. So you must name 2 different facts for each of these computational thinking aspects. Right. I'm going to just make this smaller because it's so big that it takes a long time to page through it. So one of the programs used by AJ Garden Services deals with customers and the services offered by the company. The program makes use of objects to hold relevant information about the people involved with the business, and is made up of a number of classes. So there are 3 classes: the gardener class, the customer class, and the video customer class. Okay, and they're going to ask you to make a class diagram for the customer class and the video customer class. So even though the gardener class is mentioned, you do not need to do the class diagram for it. But let's go and read about it because you still need to understand what it's about. So the gardener class, this class will be used to instantiate gardener objects, 1 object for each gardener employed by AJ Garden Services. A gardener object will have the following fields, a name, which is a string, and skills, which is a string of up to 4 characters. And this is what it can be. You can see they're all parts of maintaining a garden, L, W, E, and P. Should not be accessible from outside the gardener class. Then the customer class. This class will be used to instantiate customer objects for each customer who makes use of gardening services. Customer object will have the following fields and types: name, string, contact number, string, services used, a string of up to 4 characters, and gardener, which is a gardener type object. These fields should be accessible from the customer class and any class that inherits from it. And then the video customer class, this class will be used to instantiate video customer objects for all customers who book to take part in a webinar, in addition to the normal services provided by AJ Services. This class inherits from the customer class. In addition to the inherited fields, objects instantiated from this class will include the following fields: date, which is a data object, and title, which is a string. And these fields should be only accessible from inside the video customer class. So they will be private. There, where it says these fields should be accessible from the customer class and any class that inherits from it, you make them protected. Okay, so those are the fields. Now it comes to all the methods. You're going to complete the class diagrams for customer and video customer classes, indicate the relationship, if any, between the classes, show the declaration of all the fields and methods of the following classes. The customer class, a parameterized constructor method accepting the following parameters: N a string, C in a string, SU a string, and G a gardener object. Then accessor methods for name and gardener, mutate methods, etc. And they give you the parameters, and a toString method. And then video customer class. Remember that this is just a class diagram. You're not actually programming these unless they ask you to further down the line. Parameterized constructor method that accepts parameters D, a data object, and T, a string, in addition to the parameters of the parent class. Accessor for date and title, mutator for date and title, and which will accept parameters D, a date, and T, a string respectively, and a toString method. So we've got to go and fill in the class diagram here. I'm going to take a screenshot of this. Well, not a screenshot, but use my snipping tool, right? So that I can move this to the right of my screen and scroll back. And we're going to start working on this. I'm going to use my little tablet so I can scribble here. And so let's see. We've got the fields. Now remember, these fields should not be accessible from outside the gardener class. I'm just going to check how the solution does this. You see, they've made them minus. Okay, they didn't make them hash. So yeah, okay, that's fine. Let's just make them minus then. All right, so let me just check. I've got my annotate on. And I'm going to do minus. Oops, let's not do in pink. No, sorry. Let's do blue. So minus. Remember, you put the field name first, colon, and the type. Remember that string, even though in Java you put a capital S, here you put a small s because this can be used in any type of programming language. So it should be generic. We don't put a capital S. All right. Sorry, I was looking at the gardener, but we're doing the customer class. So let's keep going from there. Right. And we're going to go contact number. So please spell your fields exactly as they are. I know it's a lot of writing, but you've got to be very precise, and that is also a string. Remember that telephone numbers are always strings, never integers or doubles, integers especially, because they start with a 0 often and you don't want to lose the 0. Okay, minus services used. Services used. Okay, colon, and this is also a string. Now, made up of 4 characters, I'm not going to worry about that now, because that's not part of the class diagram. That is part of abstraction. I know that that is not relevant for where I'm at in this part of solution, so I can ignore that. Okay, then gardener, gardener. So minus gardener with a small g. And remember, colon, gardener with a capital G, because that is the class. All right, and so that is all for the fields there. And let's go and do the fields in the video customer. We have got this. This is going to inherit from the class above. So how you do that? You draw an empty arrow like that to show that video customer inherits from customer. And then we just add the fields that are extra fields for video customer. So minus date, colon, capital date with D, and then minus title, colon, string. Okay, and I see I'm going to run out of space for my methods here. Okay, anyway, let's keep going. So now the methods. Okay, so we've got a parameterized constructor accepting the following parameters. Now, this is going to be a plus, because all our methods are usually plus public. Okay, remember that in the class diagram, you name your constructor constructor. Even though if you're programming this in Java, you're going to name it customer, which is the name of the class. Okay, then you've got all your parameters in colon string, comma, cn colon string, comma, g colon gardener. Okay, sorry, I'm just writing outside the block, comma, okay, and that's it. They haven't got services used. Oh, I skipped services used. Oops, let's just erase here. Sorry. Okay, it's got su string, colon string. Please name them exactly as they're given. Don't make up your own abbreviations. And G colon gardener. So 4 fields, 4 parameters. Okay. Then accessor methods. Accessors are the getters. So it's get accessor method for name. So get name. Bracket, bracket. What does it return? It returns a string. So that's how you put it. Then plus get gardener. Oh, this is very slow. Colon gardener. Okay. It's going to return a gardener. Then plus mutator methods. So mutator methods are void. In other words, they do not return data. So it's for services used. So it's going to be set services used. Remember, you changed the S to a capital. Services used, brackets. This is going to need a parameter. And they tell us we must use SU colon string. Oops, string. Okay, and plus set gardener. And brackets G colon gardener. Okay, and then a toString method that will concatenate the various fields and into one string object. And you know that your toString is like spelled like that, toString bracket, bracket. It does not take parameters usually, colon, and it returns a string. Whoops, there you go. Okay. Now my methods, sorry, I've run out of space at the bottom here. What are we going to do? And if I scroll up, it's going to, the writing is all going to be out of sync. Okay, I hope you've all seen that, or shall I try and carry on down here with my methods? Okay. A parameterized constructor. So that's going to be plus constructor. Brackets. That accepts parameters D data object and T in addition to the parameters of the parent class. So all of the parameters of the parent class, N colon string, CN colon string, SU colon string, G colon gardener, we need these here too first. So we need to copy them all in N colon string, comma, CN colon string. Sorry, my colons do not look like colons, comma, SU colon string. Ooh, really difficult writing here at the bottom of the screen. G colon gardener. Okay, we've got the 4 parameters from the top. Now we add the 2 that they've added. D, which is a date. So D colon date, comma, and T colon string. Remember, always a lowercase s for string, close brackets. Now your accessor methods for the date and title fields. So it's going to be plus get date, bracket, bracket, colon, capital D date, and plus get title. Okay, the rest of them I'm not going to write out for you. I hope you try this all out on your own. I'm going to clear the drawings and let's go and look rather at the solution now. I'm going to drag it over here. Did that. Okay, just, yeah, we put that on the right. Okay, let's go back there. Right, so here is our solution. Do you see it had minus names, colon string, minus contact number, colon. Okay, we had all these fields, had all of these. We had all of these. We had our empty arrow there. We had our plus constructor with all the fields. Have a look. Let me just point that out to you, highlight that to you. These fields, right? They added one, ns colon integer. Where did that come from? I think that's a mistake, sorry. And then all of they're the fields, okay. So all of those fields, sorry, no, wait, actually not all of them. I wanted to show you, it's just the first 4 are exactly the same as the ones in the previous class, in the parent class. And then we add D colon date and T colon string because they told us here. Okay. And those are also the fields. So you would expect them to be there, all right? And there's our get date, get title, colon string, set date, plus set title, T colon string, and they forgot the toString. A toString method that will concatenate the fields. It looks exactly the same as the one at the top. And I also see that, you see how easy it is to make mistakes in these? In the solution, the brackets are missing there. All right. Anyway, so that was for 10 marks. Okay, let's look here. Where does it tell us? There, you see, 10 marks. And the 10 marks includes, okay, it tells us here how they're going to allocate it. But they want you to have every single little detail right. Please learn how to make these class diagrams, and not that difficult, right? As long as you are prepared to keep reading. What are my fields? Put all the fields in. Remember to make them minus or plus. Remember to know how to do a static field, how to do a constant. A static field is just underlined. I will add the rules for making class diagrams under the video. Okay. Here are a whole lot of sort of the next part is all sort of more theoretical questions, except, okay, here you have to write a bit of code. So write Java or Delphi code for the constructor method of the video customer class. So I'm a Java teacher, so let me look at the Java with you. So it's going to be here, public video customer. Then I don't know why they've got 2 brackets. What? No, this is not Java. Okay, let's rather type it out. Okay, sorry guys. Okay, let's do the constructor. So it's going to be public, the constructor for the video customers. So we would need our class diagram. Sorry, that's not the class diagram. The class diagram is hiding over here. Let's shift it to the left. There's our, that's for video customer. So this is plus constructor in colon string, that whole one. That is the one we want. Okay, so let's just go public space. And the constructor is going to be video customer brackets. Now remember where it says in colon string, we're going to say string n, comma, string cn, comma, string su, oops, comma, gardener g, comma, date is local date. I think if you put date, you would still get the mark. And string space t. Ooh. Oh, sorry, t. Okay, now you put our curly brackets, and then we're basically gonna have to go through all the fields and say name equals n. Oops, now the problem with Word is that it loves putting capitals at the beginning of the line. Okay, and we want contact number equals CN. Semicolon. Next, services used equals SU, semicolon. Next, gardener equals G, semicolon. Next, date equals D, and next, title equals T. And close your curly bracket. Now that would be the constructor. Okay, let's go and just minimize that. So, sure, 5 marks. Okay, that was for 5 marks. It didn't give you a lot of space. I don't know, it's a bit strange, but that is what you would have to do in there. All right, 7.2.2. In the class diagram in question 7.2.1, you were instructed to include certain methods in the class diagrams. What is the purpose of an accessor method? What is the purpose of a constructor method? That is all sort of theory of, right, that's my, let's put the solution here, back up on the right. Oops. Oh, sorry, we're getting a bit, let's keep that on the left. Hold on, where is the solution? That is the one, and we want that on the right. Okay, so here are all the answers. An accessor method, okay, I would tell you my definition. There's a formal definition. My definition would be an accessor method allows you to get the data out of the class. It returns the data that is private, from a private field to wherever it's been called from. A constructor method allows you to instantiate an object of a class. It stores the data from the parameters into the data of the fields. give an example of when the mutator method for services used field would need to be used. Let's just see what the answer says. It would be used when a customer changes the services that he or she makes use from the list of options that AJ Garden Services provide. You see, that's where maybe it is useful to read all the detail, because you would know. They offer, remember the question said, let's go and look quickly. They offer lawn maintenance, weeding, edging, pool maintenance. So when they want to change and they say, it's winter, I don't need pool maintenance anymore, take the P off. So they want to change their services used. That is when you would need to use the mutator method of the services used mutator method. Okay, that's what the question asked. Does a video customer class make use of information hiding? And the answer is yes, because all the fields are private. Okay, they say that's set as protected, therefore they cannot be accessed from outside the class. Okay. And then would any of the methods you included in the class diagrams in question 7.2.1a be classified as static? No, there are no static fields or methods in these classes. You know, if you read the questions, they never asked for static methods, so no. All right. And now we get to, I like this question. Okay, this is the truth table. So a number of the IEB programs have been written for AJ Garden Services that have decisions in them. One class has some code that looks at the array of skills of a gardener and compares them to the array of services that a customer contracts AJ Services to provide. This will link to a promotion that AJ is going to run, offering a combination of services at a special price. And remember that L is lawn maintenance, W is weeding, E is edging, P is pool maintenance. And so what they're looking is a combination the programmer is looking at currently is for a customer who wants to use lawn maintenance and edging or pool maintenance. So this would be the combination, L and brackets, E or P. Or you could rewrite it, instead of the and, you put a dot, instead of the or, you put a plus. So you've got to complete the truth table. Truth tables, if you know your ors and your ands, then you should not find these too difficult, right? So where it says E or P, there, remember that we're going to focus on this column and this column. Okay, E or P. So we're going to keep looking at 0 or 0 is 0. Now, I know in one of my recent tests that I marked, people hadn't studied these, and they kept telling me that 1 or 1, because they saw a plus there, they told me it was 2. Please don't do that, okay? Truth tables can only contain noughts and ones. Can't put 2s in truth tables, all right? You could treat the plus as a plus, because 0 plus 1 is 1, 1 plus 0 is 1, but when you get to 1 plus 1, you're going to get stuck. So remember that 1 plus 1 in a truth table, put a 1 if you don't want to learn your ors and ands. But yeah, rather, please understand what ors and ands is, and look at my previous video all about truth tables if you want to really understand them well. Okay, so we've got 0 or 0 is 0, 0 or 1 is 1, 1 or 0 is 1, and 1 or 1 is 1. Okay, next. All right, and let's just ignore those now. We're going to keep highlighting which columns we're looking at. We want L and E or P. So this time, let's maybe change colors. We want column L, that's the column we're going to focus on, and column E or P, right? And we're going to AND them, right? So remember, in an AND is only true when both inputs are true. So 0 and 0 is 0, 0 and 1 is 0, 0 and 1 is 0, 0 and 1 is 0, 1 and 0 is 0, 1 and 1 is 1, 1 and 1 is 1, 1 and 1 is 1. Now, if you want to, they want you to interpret your results and say whether it's true or false. If you see a note there, it's false. For all the notes, you can put F, and all the ones you can put true. Sure, that was much quicker for 7 marks than all the work you had to do for the previous 10 marks. Yeah. So please study your truth tables. All right. Oh, sorry, let's erase the whole thing. Okay. Next question. Consider the following algorithm that has been written to be coded into a method that will be used to add a skill for a particular gardener. The method will assign values to the following variables. Skills is a string that shows the current skills a gardener has, and new skill is a character representing the new skill that needs to be added to a gardener's list of skills. Other variables are defined for specific use in the method. A test will be performed to check to see if the value new skill already exists in skills. If the skill exists, a warning message will be displayed. If it does not exist, it will be added to the list of skills the gardener has with a message to confirm this, as well as showing the new list of skills. This algorithm has been coded, but it does not produce the correct results. You need to complete the following trace table to show that what the algorithm is doing, and you need to include the line numbers as reference to the line of code in the algorithm. There are, what does it say? Something's going on with my Adobe document. Okay, there are more lines on the grid than are necessary for a correct answer. Let's go to this trace table. I'm going to take a screenshot of it again, and we will do it on the right here. 10 marks, guys. Nice. If you do this carefully, you can get those 10 marks. Okay, well, let's look at it. I'm going to draw on this on the page again here. All right. Not in pink. Let's do blue again. All right. So remember that the way a trace table works, you are working through the program from top to bottom. When you get to a for loop, you have to keep going round and round and round the for loop until the loop ends. If you're doing an if, be careful, only do the part that is true in the if, okay? But that is basically how a trace table works. Remember, these are the line numbers. Please make sure to note the line numbers in the line column as you go. Very important. All right. And it will help you keep track of where you are in the program. All right. So line number 1. What happens? And do you remember, please, sorry, before we carry on, do you remember that the person who ever set up this table for us would have gone through the program from top to bottom, and as they came across a variable, they would have made a column for it. So skills is the first column. New skill, there's another variable, there's another column. Flag is another variable. It's a Boolean, but it's a variable, so there's a column for it, etc. As we go through the trace table, each column will match up to a variable in the program or in the algorithm. So in line 1, what happened in line 1? The variable skills got the value LWP. Okay, you don't have to put the quotes there, it's fine, just LWP. It just shows us it's a string. In line 2, you can put the quotes if you want. I'm not going to. The variable new skill got the value E. In line 3, the variable flag got the value false. In line number 4, the variable size got the number of characters in skills. Ooh, I think that's 4, isn't it? Maybe we better just scroll back, remember? Well, yeah, the number of characters in skills. Let's see, skills is a string that shows the current skills are gone. Oh, in skills. Okay, skills meaning the current value of skills. Okay. If we look at skills, how many characters in there? 3. Right. That's what we want. Size is the number of characters in that skills string at the moment. This one's got 3 characters. Line 5, what's going to happen? Let's make a note. Line 5, for k equals to 0 to size minus 1. Our size is 3, so it's going to go up to 2. Increment by 1. The inc stands for increment by 1. It's like when you put I++ on the end of your for loop. Right? So in line 5, for k equals 0. K is going to start at 0. If you understand, remember how for loop works, this is the beginning value of your for loop. When the for loop just first starts operating, that is the value. All right, line 6. If character at position k in skills equals new skill, so we're looking at the character at position k. Position k is 0. So that's got to be position k is character 0, which is the L. All right. So is the L equal to new skill? What's in new skill? E. Is L equal to E? No. Right. And you see they've actually put the question here, the if skill square bracket size equals new skill. All right. That's a bit more Java-ish, the way they oh no. Did I just clear everything? Sorry. Let's start again. LWP 2E. Sorry, I meant to flag false. I'm just going to put an if and 4. Size is 3. Line 5. K starts at 0. Line 6. We're checking, is the L equal to the P? No. So we can put a false there. All right. So it's a false. So we're not going to do flag equal true. We're going to go to straight to line 8. Nothing happens because it's just an end if. Line 9, nothing happens. It's just an end if. But if we're at the end of the for, we need to branch back to line 5 and go increment by 1. We're going to increment k by 1. So we're going to go to line 5 and increment k by 1. Where's the column for k? Look for the column for k. K goes from 0 to 1. Okay, we'll go to line 6 and check. Is the character at position k in skills equal to new skill? Is skills square bracket size equal to new skill? So is the W, because remember k is 1 now. So we're looking at character W, that character. Is W equal to E? No, it's not. It's false. So we're going to skip to line 8, and that's just the end of the if. Line 9 is the end of the for, and jump back to the top, line 5. Now we're going to increment by 1 again, so we get to 2. K goes to 2. In line 6, we're going to say if the character K in skills equals new skill, is the P equal to K? Oops, no, sorry. Where am I? Is the P equal to K? I meant to erase my arrow, and that's where I went wrong last time, right? So P is not equal to E. So the if character at position, I'm just going to show you something. What they've put here, character at position K in skills equals new skill. That is that. Okay. You have to know your Java to understand this. Your programming. Otherwise, you may not have recognized that, but that is what is meant there. All right. So we are going to do nothing. We're going to just jump over line 8 and 9. I'm not going to put them in because I'm scared to run out of space. So we go to line 10. And if flag equals false, our flag is false. We never set our flag to true. Our flag, we can look all the way up column the column for flag and check what's the latest value for flag. It's F, okay? So yes, our flag is still false, so that is true. Flag equals false is true. I'll put a true there. Then we must say skills equals new skill. Line 11, skills equals new skill. Line 12, I'm just doing exactly as they're telling me to do, as the code says, not saying whether it's right or wrong, just doing what it says. Okay, that's what you're expected to do in a trace table. If you see an error in the algorithm, don't correct it, just do what the algorithm says. Because we can see, why is it making skills equals to E? It should be adding it on the end of the line, but we'll just make it equal to E. Display new skill added. So you put here in the output, new skill added. And then line 13, full skill list. I'll just put full list. I'll run out of space there. Plus skills, E. Okay. The else we're not going to do because our flag was true. So we can skip over line 14, 15, 16, end if. Okay, we are gonna, our program is now gonna end, all right? So that's the end. You can put here that we've gone to line 16, end else, and end if. That's the end of the code. Right, and that's the end of your trace table, all done. And that was, let's just check how many marks was that for. 10 marks. Okay, if you got that all right. Shall we check ourselves on the memo? Let's put the memo here. Okay, does look about the same. We've got LWPE, F, 3, naught, F, 1, 2, F. Yep, okay, looking good. We should get 4 marks for that. Right, so let's start again. Let me remove all these annotations. Last question is the JSON files question. Now, please learn your JSON files and their format exactly so you can answer this type of question. And let's just read it. JSON files are flexible and language independent, allowing for easy manipulation of JSON objects. Consider following JSON objects representing 3 gardeners employed by AJ Garden Services. We've got the whole format of the JSON, curly bracket, name, colon, CMO, skills, colon, WEP, and you can see each gardener has a name and their skill set, all right, indicated by a letter for each. What is the name given to each of the 2 items representing the name and skills? So each of these pairs is called a key pair or a key, okay, key pair. And we now want to store the details of several gardeners who work for AJ Garden Services using a JSON file. This will be in the form of an array named gardeners, and you need to combine to complete the following structure for the gardeners listed in question 7.5. So if you knew your JSON files well, I'm not going to write it all out for you. Let's put it on the right here. This is what you would have had to put. So you've got your, they've put curly bracket, quote, gardeners, quote, colon. The next thing you had to do was put a square bracket and then basically copy this out, right? Exactly as it is. Oh, except you see they put semicolons here. There should be commas, okay, between the key pairs. All right, and then close the square bracket there, and then close the finally curly bracket there. Okay, and if you did this well, you got 5 marks for your JSON. Basically, all you had to be careful with here was your square brackets. You had to know there were square brackets and that the key pairs were separated by commas and not semicolons. So lots of marks for knowing a little bit. Right. So keep studying your data and information management and solution development. It's worth a lot. And I'll see you next time.